Hi, welcome to the ninth lesson on electricity. In this lesson, we're going to cover AC and DC, also known as alternating current and direct current. Now, so far we've mainly focused on direct current, but alternating current plays a massive role in our everyday lives, and we can actually see it using our smartphone cameras. Here we have two videos of the same place side by side, both recorded in slow motion at 240 frames per second. The only difference is that one's at night and the street light is turned on. And we can clearly see that this street light is flickering. This is due to the alternating current supplied. By the end of the video, hopefully you'll be able to note why the car lights you can see here are not flickering. Try this out yourself at home. This works on LEDs and filament bulbs, but it doesn't work on CFL bulbs. Now, there are two types of current: direct current and alternating current. The light flickering we saw before was a result of alternating current. Let's take a look and see what these two types of current look like in reality. Here are two circuits. On the left-hand side, we have a circuit powered by a battery. And on the right-hand side, we have a circuit powered by a mains power supply, an alternating current power supply. Let's switch on the circuits and see what happens. Here we can see the electrons passing through the circuit in one direction. And as a result, the bulb remains at a constant level of brightness. This is the type of current we've learnt about so far, and this is known as direct current. On this side, we have an alternating current supply. This one's quite different. As we can see, the electrons aren't passing in one direction, but they're alternating. They're alternating very quickly and constantly changing direction. As a result, the brightness of the bulb changes and the bulb actually flickers. This is what we saw before. Let's go back to our table. Now, as we saw, in direct current, the electrons move in one direction only, whereas in alternating current, the electrons are constantly changing direction, moving from the positive pole to the negative pole. Direct current looks something like this, with all the charges, all the electrons, flowing in one direction, whereas alternating current looks something like this, where the electrons, or the charges, are alternating in direction. They're flowing in one direction at one moment and flowing in the opposite direction the next moment. If we were to look at this graphically on a graph, our direct current would look like this. At a constant level in one direction, in this case in the positive direction. As alternating current is slightly different, it switches between the positive direction and the negative direction and looks more like this. It's constantly changing from the positive to the negative, then back to the positive, and then back to the negative. Direct current is generally supplied by batteries and cells, whereas alternating current is supplied by the mains. Essentially, the electricity that powers houses. It's extremely important to know that electricity supply in the UK is alternating current. That's why often the light bulbs in our houses, when viewed in slow motion, generate an alternating current flicker. This main supply is at 230 volts, and if you looked at that flicker in detail, you would see that it happens 50 times per second. That's because the charges change direction 50 times per second. Thinking back to our lessons on waves, 50 times per second, how else could we write that? So the charges actually oscillate at 50 Hertz, or the electrons in our mains supply, in our houses and in the street, change direction at a frequency of 50 times per second, a frequency of 50 Hertz. Now that's it for this lesson. I hope it's been useful. If you have any questions, please do ask.